Welcome to our video. In this video, I will introduce our research titled Ammonia, an approach for deriving project-specific bug patterns, which has been accepted by Journal of Empirical Software Engineering last year. Here is a snapshot of web page of PMD, which is a popular statistical analysis tool. The overview says PMD is a statistical analyzer. It finds common programming flaws like unused variables, empty catch block, and unnecessary object creations. The underlying idea of statistical analysis is there are some commonly occurring bugs across all software products, and such bugs often have identifiable patterns. Therefore, statistical analysis tools employ a set of rules for commonly occurring bugs and scan the target source code. However, we consider there is an issue in current statistical analysis tools. That is, current statistical analysis tools do not contain any specific bug patterns that are part of a particular target software project. So in this research, we try to detect potential bugs by using project-specific bug patterns deriving from commit histories. I will explain why we consider mining commit histories works for deriving project-specific bug patterns. This slide shows a real bug occurred in Project Camel, which is included in Apache Software Foundation. This bug has been already fixed by a developer. And this is the patch to fix the bug. The red line is the buggy code, and the green line is the fixed code. This slide shows another bug occurred in the same project. This bug has been already fixed too. And this is the patch to fix the bug. Here we compare the two patches for the different two bugs. We can see that the buggy code and the fixed code in the two patches are very similar to each other. Only the difference between them is variable names in the code. So we can derive this change pattern from the two different bug fixes. In this change pattern, only variable name is normalized. And in this change pattern, some methods defined in this project are invoked like this. So which means this pattern is a project-specific one. As shown in this example, we can derive project-specific bug patterns by mining commit histories. Next, I will explain the procedure of our approach. For a given project, our approach extracts changes from every consecutive pair of revisions. Then our approach make a pattern from a set of changes whose before change code and after change code are the same. Our approach also counts how many times each pattern occurred in the commit history, like this. Next, I'll explain how our approach detects buggy code in the latest revision. Our approach checks whether the latest revision includes the left-hand code of this orange change pattern. If it does, our approach recommends the matched code be replaced with the right-hand code. Of course, the same things are done for all the other change patterns. Next, I will talk about evaluating our research. The purpose of this evaluation is examining the ability of our approach to detect potential bugs. We used these for projects included in Apache Software Foundation because these projects assign a unique ID to each bug occurred in the project. And the commit message of bug fix commit includes corresponding bug ID. Thus, we can judge whether each commit is bug fix 1 or not. In this evaluation, we made pull request based on the detected potential bugs. Now I will explain how we did the experiment. First of all, we detected change patterns whose changes occurred at least once in the bug fix commit. And as a result, we detected a large number of change patterns as shown in this table. And next, in step 2, we extracted change patterns whose right-hand code are the same for all the changes. I will show an example of this extraction. In the left side case, 3 code fragments are changed. The 3 blue code fragments are very similar to each other. And only one of them is changed to the red code, and the other 2 code fragments are changed to the yellow code. This means there are 2 change patterns in the left side case, and their before change code are the same, while the after change code are different. In other words, the 3 blue code fragments are changed in different 2 ways. We do not use change patterns derived from such a case. And in the right side case, 3 code fragments are changed, and they are changed in the same way. In such a case, we use change patterns. We obtained those number of change patterns as a result of step 2. Next, we detected potential bugs by using those change patterns. In this evaluation, we extracted patterns that match only one place in the target code. And then in step 4, we manually investigated whether that matched code is buggy or not. And unfortunately, we couldn't determine whether the matched code is buggy or not for some patterns because we are neither the developers nor expert for the target project. And in step 5, we sent a pull request for the buggy code via GitHub. This slide summarizes 6 pull requests that we made. For example, for Ant, our approach suggested move method invocation outside the loop. And for Camel, our approach suggested to invoke a different method. And those numbers means the ID of pull request that we made. If you are interested in, you can see the detail of the pull request in the GitHub repository of the target project. At this moment, 5 out of the 6 pull requests have been merged. Only one of them was rejected. The reason why the pull request was rejected existed in the code. The code comment just above the matched code says, do not optimize this loop by replacing children.size by a variable, as children can be added dynamically. In investigating whether the matched code is buggy or not, we missed the code fragment. Okay, now I conclude my presentation. In this research, we conducted we proposed an approach to detect project-specific potential bugs, and we detected the tool chains. We developed tool chains for the approach, but due to time limitation, we couldn't introduce them in this presentation. But you can download the tool from this URL. We conducted the developer-involved experiment, and 5 out of the 6 pull requests were merged based on bug-related issues, and 4 out of 5 pull requests were merged based on non-bug-related issues. This means kind of refactoring. But the latter case, I couldn't explain due to time limitation. If you are interested in, you can download the replication package from this URL. That's all. Thank you very much.